Thank you, Craig, for outlining the RPI SMIC's value proposition for SESMII members. Next, we'll hear from Vice Provost Jim Davis, Professor Panagiotis Christofides, and Dale Turner about the UCLA SMIC and its satellites.
So it's very much my pleasure to lead an overview of the UCLA Smart Manufacturing Innovation Center and satellites. I'm joined with my colleagues today joined by my colleagues Panagiotis Christofides and Dale Turner. We'd like to give you an overview of this innovation center. And I want to note before we dive in that we are representing a large number of people who are involved with making this innovation center work and function successfully. Next slide, please. So the UCLA SMIC and satellites gets its name because there were 4 institutions that came together to form a network of capabilities. So it's a closely coordinated network. So that's where the name SMIC and satellites comes from. But the 4 institutions are UCLA at Los Angeles, El Camino Community College, Atology Incorporated in Santa Clara, California, and Oregon State University in Corvallis, Oregon. Like the other innovation centers, we provide a broad spectrum of member engagement opportunities, in this case up and down the state of California and into Oregon, the western region. But we also have a unique capability in that we take advantage of our co-location with the development of the Smart Manufacturing Innovation Platform and the Smart Manufacturing Profile Development. And we would like to highlight that first and then broaden back out to the member engagement capabilities. So as I mentioned, we're taking this co-location capability, we're leveraging it very, very strongly. If I can draw your attention to the right-hand side of this chart, the Smart Manufacturing Innovation Platform underpins a set of what we've been calling smart manufacturing building blocks. If you look at the dark ovals, you see sensing, contextualization, analytics, optimization, and control. The Smart Manufacturing Innovation Platform is designed to provide or facilitate each of these to go forward. In the blue box, or in the blue cylinders, you see data, information, insights, and intelligence. So what we're doing is basically with the sensing, taking data and moving into basic control. With the contextualization, we move into management control. With the analytics and the insights, we move into more recognition with these kinds of systems. And then with the intelligence and the optimization, we move into decision-making and higher level control. So this is a platform, this is and its success actually depends on the ability to build applications, and that's where the Innovation Center comes in. What we're doing is building applications and demonstrating how to use the platform. So the lower right-hand corner, smart application building, we've been focusing on AI machine learned models, and we're really doing 2 kinds of things. One is modeling system phenomena, and then the second is taking that phenomena and then turning it into and using these building blocks to move into recognition, decision, and action, the control function. And we're demonstrating then how you can move those kinds of capabilities into production and the orchestration of all the different features that are needed. So the co-location capability and what we want to emphasize here is that we're pressure testing the practice of engineering these applications using these new smart manufacturing capabilities that SESMII is building out. So the blue box on the left are the 4 main functions that we're doing here: pressure testing and measuring. We're documenting and showcasing, and then we're closing the loop with these system models to build out this higher and higher levels of control functionality. And I will also mention that we have built out process and machine operations capabilities so that we're demonstrating the full gamut of these capabilities when testing the platform. I'd like to now turn it over to Panagiotis Christofides, to show how this translates into a process application.
Thank you very much, Jim. Can we go to the next slide, please? So this is the work that we are doing within the Department of Chemical Engineering here at UCLA. I represent a very large team of about 50 people who work on this project, and the focus here is an electrochemical reactor. The objective of this reactor is to convert CO2 and electricity into a variety of hydrocarbon products. And we use this reactor to be able to understand complex phenomena that take place in this process, like transfer phenomena and reactions. And we have a series of sensors that we use to generate data for this process that we then use to build out machine learning models that can allow to have optimal, from an energy point of view, operation of the reactor, as well as use these sensors to be able to understand issues that occur in this process from a first principles perspective, and ultimately use these sensors and the models that we develop for real-time optimization and feedback control. Using this sensor also, we can develop the profile libraries. So we use the data, we understand how the sensors behave, what is their sensitivity, and we update the profile libraries to be able to provide information about the insights and the understanding that we get from our system into manufacturers and other colleagues that use similar sensing systems. Next. Here's an example of machine learning modeling in the context of automating gas chromatography, which is an important sensor that we use in this reactor to measure concentrations of gas phase species. Typically, this is a manual task that is done, as the sensor can provide information every about 20 minutes, but we have developed machine learning tools to automate both the data analysis in terms of identifying the peaks in chromatography, as well as developing models that allow us to estimate what are the concentrations of species of interest in much shorter time scales, in the order of second time scales. That is information that can be used in the context of feedback control. And we use a variety of state-of-the-art machine learning tools to accomplish this task. Next slide, please. And here is another area that we are moving into. We want to be able to develop control systems for this electrochemical reactor for energy efficient operation. So we are going to take advantage of all of the sensors that we have for our system. We develop machine learning models using the data from these sensors that are used directly in the feedback control systems, which eventually will be of model predictive control type. And these controllers will allow us to do both real-time optimization, feedback control of the process operating conditions, with objectives that we would like to achieve, ranging from optimizing economics to energy, as well as meeting safety requirements. Another important aspect for this work is that we have automate the process of creating these machine learning models for reactor operation, as well as updating these models in real time using data that come from the reactor sensors in real time. And therefore, these models can also be used directly in the model predictive control systems. Here I will just list the team that were working on this project that involves the groups of Professor Davis, Professor Morales-Guyo, and myself. Next, I think Dale will continue the presentation.
Thank you, Panagiotis. Next slide, please. The importance of this is it gives you a snapshot of the UCLA SMIC and the satellites combined together. And if you look at the bottom of the chart, it shows the specific manufacturing assets that reside at each of our locations. So on the left side, you'll see what Panagiotis described. Also, UCLA will have a machine lab connection to the platform. and then you'll see El Camino as ECC, and then Ecology and Oregon with their specific assets. These basically connect to the platform, which is in the middle. And then if you look at the upper layer, these are some of our current software application vendors we work with. And we have plans to expand that further. So we're able to take what we have as our technology base and capabilities and then be able to apply it toward industry real problems. El Camino, as Jim mentioned earlier, they're located in Southern California here in Torrance, serves as our satellite for our intensive workforce development training. They have a hallmark of training that they're part of a California statewide network of 115 community colleges. So it's a really big network of a network, and El Camino is key in that deployment. The other thing that we're excited to talk about a little bit is our catalog of smart manufacturing courses that are going to be available. So if you have any interest in these courses, please reach out to Jose. His information will be on the slides that will be shared at the end of this presentation. The other important thing of this is that we're going to be expanding the satellite into the El Camino's Automation, Robotic, and Manufacturing Center, known as the ARM, where we'll be connecting that into the platform, and that will allow current industry incumbent workers to come in and actually learn how to do smart manufacturing in a true operational cell. So we're really excited with this expansion, and we plan to have an outreach event in January timeframe where you'll be able to welcome to come in and see this in action. Ecology, as Jim mentioned, they're up in Santa Clara County, known as Silicon Valley. Here we have an extensive network of AI, artificial intelligence, camera-driven visual analytics that we have from a camera-based. The importance of this is it's able to help us identify some of those uncensored items on the machine that are real-time interaction of a user, an operator, or even material being fed into a manufacturing environment. They also serve as our Smart Manufacturing Innovation Platform Demonstration Center, where you're able to actually go and get a view of the platform itself, or even set up a remote a meeting with Rob to see the platform in operation. And we as well plan to have an opening in January timeframe where you'd be able to come in and see this in operation. Oregon State, Corvallis, a really nice town up there. We're really proud to have them serving as our Northwest satellite for those upper U.S. states up there. The importance of this partnership with Oregon State is our alignment with the Industrial Assessment Center, which is a DOE program that does assessments to manufacturers of all sizes, small, medium, and large. So what we've done is we've combined the industrial assessment program along with ours, where with Oregon you could get a free entry assessment and help you build a roadmap out to what we've applied to it for a smart manufacturing assessment journey as well. So this will really help us expand a plan that will be deployed across the U.S. at the other IAC centers, so we could work hand in hand in order to help small medium manufacturers in the journey of smart manufacturing. Also, the importance of them is the aerospace and food beverage sector up there, so they bring a lot of that to the program. And so if you want, reach out to Carl to get your free energy assessment. So how's this all come together? It's pretty exciting. You know, as Jim described earlier in the opening, We have these four assets by locations that make up the UCLA SMIC and its three satellites. If you look at the matrix, it's pretty important. It gives you an idea where when you have those problems or need help in a engineering manufacturing solution or training, it gives you the ability to look at this chart and then be able to continue who you talk to in order to get more engagement and address some of your industry needs. So again, this provides a breadth and depth of our capabilities that we serve here. If you're a current member and you want to understand more on the SMIC and the satellite capabilities, you could go into the members portal and you have access to go further and understand their offerings. And then if you don't have access to the portal, again, the information's on here, or you could reach out to myself or any of the individuals. Thank you.